Hello and welcome. In this lesson 10.2 we'll be modeling using perimeter and area. In this first example we've got that John wants to put a fence all the way around both the dog park and the playground that's next to the dog park, as shown below in this diagram. He wants the area of the playground and the dog park to be the same. John has 78 feet of fencing to work with and wants to use all of the fencing. Alright, so let's look at some things here. This example is a little bit more complex than just the initial idea here of the perimeter being 2x plus 2y, or sometimes you'll see it written 2w plus 2l, which is 2 times the width plus 2 times the length. And if we just had one rectangle, that would be fine, or two rectangles that weren't joined, that would be fine too. But in this case, we're going to have, for the length of the fencing, is going to require also the length of y in between the dog park and the playground. So it says write an equation for the perimeter of the dog park and the playground. Solve the equation for y. So we'll go through and we'll say, okay, we've got y once, twice, 3 times, and we have x 1, 2, 3, 4. And so let me see. So our perimeter, we'll call it perimeter even though it's maybe technically speaking not perimeter because it has that y in between the dog park and the playground, but we've got 3y plus 4x. And then we want to solve the equation for y. So first we'd subtract 4x from both sides. And that would give us p minus 4x equals 3y. And then we'll divide both sides by 3, and that would give us y equals p minus 4x divided by 3. Now, B, it says, using your equation from part A, write a function for the area of the dog park in one variable. Okay, so area of the dog park. Now, the area of the dog park would be length times width, or x times y. And since, we'll just go ahead and write that. The area equals x times y. Now, let me highlight this. Y equals p minus 4x over 3. And so we can just put that in here for y. And when we do, we get x times p minus 4x over 3. And that then would be the function for the area of the dog park in one variable. Graph on part C, graph the function from part B. Be sure to label the axes and indicate the scale. Okay. So at this point, I think it would be before we do that, let's go. We don't have this in one variable because we have this p, but we do have, let's use blue. John has 78 feet of fencing. And so that would be the perimeter that we're looking at. And so we can rewrite this as x times 78 minus 4x over 3. And that would be the area. And so now when we're graphing this, I think it would be nice to go and use either graphing calculator or Desmos. I like using Desmos. So we go over here to Desmos, and it says we enter in Desmos, start graphing. We're going to enter in x parentheses. I'm going to open another set of parentheses inside that, 78 minus 4x minus 4x, and that's all divided by 3. Then I close the parentheses. And that has given us our graph, which if we zoom out far enough, we can see that it's a parabola. And it crosses at the origin 0, 0 and 19.50. So this is graph the function from part B. Be sure to label the axes and indicate the scale. And so I just did a quick sketch. Didn't draw it as pointy as the other one, but it's fine. I can go back. And see that it goes up to 126.75. So I'll put 120 here, and I'll put here at the point. .75 and 126.75. And then this point down here would be 19.5, 0. So on D, when it says what dimensions will maximize the area of the dog park, we can say that the area, the value of x would be 9.75. And then we can go back to our equation from part A and say the y equals the perimeter, which we know is 78, minus 4x, but there instead of x we'll put 9.75, and that's all over 3. And then we'll put that in the calculator. When we put this in the calculator, we see that y equals 13. And just to double check, all of these are feet. So y equals 13 feet, x equals 9.75 feet, and we can say that the maximum area is at 126.75 feet squared. Well, they didn't ask us for that detail, but I think it's important to know. So then, so we'll move on and do the next example. So this next example says the maximum size envelope that can be mailed with a large envelope rate is 3 inches longer than it is wide. The area is 180 inches squared. Find the length and the width. So I find that it's useful. In the last problem, they had already drawn us a diagram, but if you don't have one, to draw it out so you can sort of see what you're thinking about. So draw a little rectangle to represent the envelope. We see that it says that it is 3 inches longer than it is wide. So this is sort of nice. We can say x, let x equal the width. Then the length would be x plus 3, because it's 3 inches longer than it is wide. And then we can say the area is length times width. The length is x plus 3. The width is x. And so putting both of these into the formula for the area gives us the area being x times x plus 3. And then they have also given us that the area is 180 square inches. And so we can substitute that in for A. So 180 equals, and let's multiply out, x times x would be x squared. X times 3 would be 3x. And then our next step would be we'd want to take 180 and subtract it from both sides, so we have this in standard form. I'm going to write it on the left. X squared plus 3x minus 180 equals 0. And now that we have it equal to 0, we can write this thing factored. X times x would be the x squared. And then for this, we're going to look for two numbers that if I multiply them together, I get negative 180. And when they combine to 3. Multiplied to negative 180 means one's going to be positive and one's going to be negative. And so with a little trial and error and exploring different numbers, you find that 15 and 12 multiplied to give you 180. And if I put the positive on 15 and the negative on the 12, negative 15, positive 15 times negative 12 give you negative 180. And 15 plus negative 12 would give us the 3 in the middle here. And so we said each of these factors equal to 0. X plus 15 equals 0. Or x minus 12 equals 0. Subtracting 15 from both sides on the left equation gives us that x equals negative 15. And adding 12 to both sides on the equation on the right gives us that x equals 12. Now, since these are dimensions of an envelope, x equals negative 15 wouldn't work because you can't have negative distances. So x equals 12 is our value for x. And 12 plus 3 would be 15. And so our width equals 12 inches. And our length equals 15 inches. All right, let's look at this other example here. Find 3 consecutive integers such that the square of the second number plus the product of the first and third numbers is a minimum. 3 consecutive integers, so we want to set that up. First, I'm going to say first, second, and third. If our first integer is some number x, they're consecutive integers, the next one has to be one more than that, so it's x plus 1. And then the third integer would be x plus 2. And so there's 3 integers. The square of the second number, so we can take x plus 1, that's the square of the second number, plus the product of the first and third numbers. There's the first number and the third number. Their product means that they're multiplied. Is a minimum. So we got this set up. We want to multiply these out. X plus 1 squared, it's helpful to use a box to multiply those out. We'll write x plus 1 and x plus 1. X times x is x squared. X times 1 is x. X times 1 is x. And then 1 times 1 is 1. So the two common terms are the two like terms are x and x. So those are x. That would be 2x. So you get x squared plus 2x plus 1 plus, and then multiply this one out using the distributive property. X times x would be x squared. And x times 2 would be 2x. So then we can combine all these that are like terms, and we get 2x squared plus 4x plus 1. And then I would recommend that we go to Desmos. And graph it. So we put in 2x squared plus 4x plus 1 plus 4x plus 1. And the lowest point of this would be its minimum. And that would happen when x equals negative 1. And so if x equals negative 1, then the second would be negative 1 plus 1, which would be 0. And the third would be negative 1 plus 2, which would be 1. And then just to try it back in the idea that 3 consecutive integers such that the square of the second number, that'd be 0 squared, plus the product of the first and the third numbers, that'd be 1 times negative 1, which would be negative 1, would be a minimum of negative 1. And that's how you would go through and do this kind of problem. Don't let these problems intimidate you as you're working on them. Do your best. If you do find that you're struggling, please reach out. Send me a call or a text. 801-413-3363. And we can set up a time and do a Zoom meeting or a Google Meet, and I can show you my screen and work through some problems with you. Good luck. Have a good day.